In this video, we're going to be talking about the vertical and horizontal asymptotes of a function. So the vertical asymptotes exist when the denominator of a function is equal to 0 or when there is a square root on the independent value. So when our x value has a square root on it, there's a vertical asymptote that exists. So an example of this would be f of x is equal to the square root of x minus 1. And that would mean that x minus 1 would have to equal greater than 0, so x would have to be greater than 1. That means that there wouldn't be any value for x, the domain wouldn't exist. So element of real numbers, and x would have to be greater or equal to 1. Another example of this where you'd have a vertical asymptote would be when you have something like f of x is equal to 1 over x minus 1. In this case here, x cannot equal to 1, because if it does, then we're dividing by 0. Therefore, the domain is x element of real numbers. X cannot equal to 1. And for the horizontal asymptotes, these exist when you have two polynomials of the highest degree in the numerator and the denominator of a rational function. So if we have something like this, x plus 2 divided by x minus 3, well here, since we have x to the power of 1 in both, well, we'd have a horizontal asymptote that is not equal to 0, and that would be the horizontal asymptote would be equal to 1. So all that means is if we had something like x to the power of 2 plus 3x plus 4 divided by x plus 1, in this case here as well, you would divide every term by x to the power of 2 and realize that you wouldn't be able to, the horizontal asymptote would be equal to 0. Alright, so the steps to take to find a vertical asymptote would be to write out the denominator and then say that it's equal to 0 and then solve for x. The answer you obtain is your vertical asymptote. For the horizontal asymptote, divide each term in your rational function by the leading x degree and replace x by a large number. We usually use infinity or something like 100,000. The answer you obtain is your horizontal asymptote. So as an example, let's do this problem right here. So to find the vertical asymptote and domain, so the vertical asymptote, we look at the denominator. So we say x plus 2 is equal to 0, and then we solve for x. So we have x is equal to minus 2. That means we have that our vertical asymptote is equal to minus 2. Because if we replace minus 2 in this equation, then we're dividing by 0, which is something that is non-defined. So if we were to write our domain, the domain would also be x elements real numbers, x cannot equal to minus 2. Now for the horizontal asymptote, we're going to take our function y is equal to x squared plus 2x minus 8 divided by x plus 2, and we're going to look at the leading coefficient, or the leading degree. So x to the power of 2 is our highest degree. Therefore, we're going to divide each term by x to the power of 2. Okay, so this gives us 1. This gives us 2 over x. This gives us minus 8 over x squared divided by 1 over x plus 2 over x squared. Now the next step to do is to plug in a really large number. So that'll be equal to 0, that'll be equal to 0, that'll be equal to 0, that'll be equal to 0. Therefore here, so we have something that is equal to 1 over 0, which means that it's non-defined, which means that there is no horizontal asymptote. Okay. If normally you'd get something that's equal to 0 or a number, but if you get something that's non-defined, that means there's no horizontal asymptote, and you can see that your range is y element of real numbers.